All right, we just need to go over the last problem. Is that the one with the committees?
Yeah.
Uh-huh. What is this? Is that like, are these like words you're supposed to know on the vocab list?
What does it say?
Eccentric, emulate, and discern. Anyway, what is the last problem in last night's homework? Number, hey, where did they go?
55.
Oh, there it is, 55. 55. The US Senate has 100 members. Suppose that it is desired to place each senator on exactly one of 7 possible committees. The first committee has 22 members, the second has 13, the third has 10, and the fourth has 5. The fifth has 16, and the sixth and seventh have 17 apiece. How many ways can these committees be formed? Okay, this is going to be a huge number, but then I guess you're going to get to use your calculator on it. Okay, now first of all, is this going to be a permutation or a combination? Since we're making committees. It's a combination. So, you have 100 senators to choose from. The first committee, you're going to pick 22 people. So out of the 100 people there, how many ways can you select 22 of them? 100 C 22, correct? Okay, now, after you pick the 22 people, how many people are left to choose from? 78. Okay, now out of these 78 people, how many people, it says the second committee has 13 people. How many ways can you select 13 of them? 78, choose 13. Now, after you pick those 13 people, how many people are left? Subtract. 65. So, of the 65 remaining people, how many ways can I select? What is the third committee? 10. How many ways can you select 10 people? 65, choose 10. Okay, how many people are left? 55 people are left. So of the remaining 55 people, committee 4 has 5 people. How many ways can you select 5? 5. Okay, how many people are left? 50. So of the remaining 50 people, how many ways can you select? What's the fifth committee? 16. So 16. How many people are left? 34 people. So out of the 34 remaining people, how many ways can you select? What does it say there? 17. How many people are left? 17. Of the remaining 17 people, how many ways can you select? 17. Well, that would be 17C 17, right? And then what do I do with all these numbers? You multiply them. Because we're using the multiplication principle, right? They're all on the committee together. Anyway, there's no way I would give you a problem like that because just this number alone is so huge. So obviously you're going to have to use your calculator to solve this. So now you're going to have to learn to punch the buttons that I taught you. Yeah? Anyway, what's the answer?
1.37.
How much?
1.37 times
10 to the 70 power. Oh my gosh, that's huge. Anyway, because I'm not going to let you use a calculator on the test. Wasn't there another problem like this, except with smaller numbers? Okay, you guys know. 53, you guys have about 49. Yeah, 49. Everybody can do 49? See, that problem is going to be on the test. Everybody can do 49? I'll walk around now. Everybody got it? All good?
Wait. What were the answers?
Send? That's fine. Why don't you guys just say yes at the very beginning? Okay, 49. I'm going to make a dance committee, and it's going to consist of 2 boys and 3 girls. If the membership is to be chosen from 4, so there's 4 total boys and 8 total girls. So from this, how many committees can you make? Well, so the committee is gonna have 2 boys and 3 girls. So out of the 4 boys, how many ways can you select 2 of them? 4C2. Out of the 8 girls, how many ways can you select 3 of them? 8C3. Now the question is, what do I do with these 2 numbers? Are they on the committee together, or, see, basically, if things can occur together, that's when you multiply the numbers. But if you have things that cannot occur at the same time, that's when you add the numbers. So in this case, aren't these 2 boys and the 3 girls gonna be on the committee together at the same time? So you multiply those numbers. So if you write that formula, like, I changed my mind on the thing. If you write down the formula, you're gonna get 3 out of 5 points. And then you gotta compute it to get the other 2 points. So how do you compute 4 choose 2? 4 times 3 over 2 times 1. Is everybody using the shortcut I taught you yesterday? 2 goes into 4 2 times, so this is 6. And then 8 choose 3 is 8 times 7 times 6 over 3 times 2 times 1. But the 6 cancels a 6, and 8 times 7 is 56. So all you have to do is multiply 56 times 6. Can you guys do that? 6 carry 3, 336. There you go. So this formula will give you 3 out of 5 points on the test, or on Friday's quiz. And then the final answer is worth 2 points. Because you guys gotta at least compute something. Okay, any other questions? Or we're done with that? Alright. Okay, so we're moving on to, what's the next one? 14.3. I'm guessing it's probability. Yup, probability. So what do we have to cover? We're only spending 1 day on this. 17 through 69. Okay, what are we doing? We're just doing probability problems. All the way to 69, 59? I'm not even looking at the right thing. There you go. 17. Are you kidding? So busy. 16 to 59. Okay, here we go. Okay, now that we know how to count, now we can do probability. Now, can I assume that everybody knows the basics about probability? Because you guys, when did you guys first learn probability? If you toss a coin, what's the probability that it's going to turn up tails? 1 out of 2, right? So, what? The probability of an event occurring will always be a number between. I thought you guys said you guys knew the basics. 0 and 1. If the probability is 0, what does that mean? That means it will not occur. What if the probability is 1? That means it will occur with certainty, right? That means Garen's barbarians, it's going to happen. But most of the problems that you're going to get, the probability is going to be somewhere in between there. Okay, now when you first learn probability, the easiest thing to do is just write out all the possibilities. Okay, let's just start with an easy problem. If I toss a coin, what's the probability that it's going to turn up tails? Well, what can happen when you toss a coin? You can toss a head or you can toss a tail. So there's only 2 possible outcomes. So that's why the answer is going to be something out of 2. What's the probability of tossing a head? 1 out of 2. What's the probability of tossing a tail? Look, just count. 1 out of 2. Easy. Okay, but now, if you took biology, I think you guys learned this, right? What if you toss a coin 2 times? What can happen? What can happen when you toss a coin 2 times? Let's write out all the possibilities. Head, head. Head, tail. See, do it systematically so you don't miss it. See, I did all the one. I do it in alphabetical order, basically. And then tail, head, tail, tail. Can anything else happen when you toss the coin twice? What?
The middle.
That's what your grade is going to be soon. Middle. There's only 4 possibilities. So anytime you ask the question, what's the probability when you toss a coin twice? You know it's going to be something out of 4. Okay, so did you guys do this in biology except boy and girl? genetics?
Yeah.
It's the same thing, except different. Okay, what's the probability of tossing two heads? Just look, right there. One out of 4. That's how you do it. You just gotta look. Okay, what's the probability of tossing two tails? 1 out of 4. You just gotta count. What's the probability of tossing a head on the first and then a tail on the second? Right there, 1 out of 4. What's the probability of tossing one of each kind? Yeah, that one or that one. So it would be 2 out of 4, which of course is 1 and 1/2, right? So if you can write out all the possibilities, probability is easy. And what do we call a listing of all the possible outcomes? There's a name for this. Hoglin. No clue.
Oh.
Guys, what is this? The zoo? What do we call a listing of all the possible outcomes? It's in your book that you're supposed to bring. Book check, 1%? Quarter average? That's it from now on. If I say open your book and you don't have it, minus 1% of your quarter average. It's called the sample space. A sample space is a listing of all the possible outcomes. So if you can list the sample space, probability is like the easiest thing in the world because then you just gotta count. Okay, now let's kick it up a notch. What if you toss a coin 3 times? What can happen when you toss a coin 3 times? Let's write out the sample space. Head, head, head. Head. See, do it alphabetically or have some kind of system so you don't miss any. Now, before I even finish this list, how many things will there be in the list? 6? No. Use the multiplication principle.
16.
No, let's use the multiplication principle. When you toss a coin, how many possibilities are there? It's either head or tail, right? 2. So if you toss one coin, you get 2. What about the second one? 2. The next one, 2. What's 2 times 2 times 2? And don't say 6. It's 8. So there should be 8 over here. Okay? So let's list them all. Head, 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 tail, head, tail, head. No, alphabetical order. You guys know what alphabetical order means. Head, tail. You guys, what's gonna happen if you get a job and you have to file stuff? Quit the job? I'm gonna hire somebody to do it for me. Okay, C. Okay, there. I did all the ones that start with H. Now let's all do the ones that start with T. T, H, H, T, H. H comes before T. T, T, H, and finally T, P, T. See how there's 8 things in there? That's all, okay. So anytime you toss a coin 3 times, the probability is going to be something out of 8 because that's how many elements there are in the sample space. Okay, so now you can answer any question. What's the probability of tossing 3 heads? Right there, 1/8. What's the probability of getting 2 heads and 1 tail? So where do I see 2 heads and 1 tail, 2 heads and 1 tail, 2 heads and 1 tail? That's it. So the answer is 3 out of 8. What's the probability of getting all 3 tails? 1/8. So if you can write out the sample space, you can answer any question. So most of the questions tonight, you're gonna write out the sample space. Okay, now let's go from coins to dice now. You guys know, everybody knows what a die is? You guys know how it, yeah. You guys know how a die works? Yeah, I know. No, because you'd be surprised. Okay, here's a 1. What's on the opposite side of the 1?
6.
Very good. How do you know? Very good, because the opposite sides always add up to 7, right? You guys know that?
Yeah.
You sure? I don't know, man. Okay, let's just roll 1 die. If I roll a die, how many possibilities are there?
6.
There's 6. Either you're gonna roll a 1, 2, 3, 4, 5, or 6. See, it's easy. So anytime you roll 1 die, the answer is gonna be something out of 6. What's the probability that you roll a 5? What's the probability of rolling an even number? 3 out of 6. What's the probability of rolling a prime number? Oh, now you gotta know what a prime number is. I like to use prime numbers in my problems, I'll just tell you that now. What's the smallest prime number? 1 or 2? No, it's 2! These are the prime numbers. You know how I know? It's on the cheat sheet. It's on the SAT cheat sheet that your teacher should have given you. Anyway, I told you, if you guys want to see the SAT, ACT cheat sheet, just email me, I'll send it to you.
Really?
Yeah. But you gotta send me an email and then I'll send it back to you. Okay, anyway, so 3 out of 6, so 1/2. Okay, but that's just rolling one die. That's so easy, right? That's the kind you do in elementary school. Now, what happens when you roll 2 dice? What can happen when you roll 2 dice? Let's write out the sample space. Now, if you learn probability, everybody should see this at least once in their lifetime right here. Then you know how things work. So when you go to Las Vegas and you gamble, you guys know how to shoot craps? You guys know how that game works? Okay, what can happen when you roll 2 dice? Well, you can get a 1 and a 1, correct? Yeah, that's called snake eyes. Okay, what else can happen? You can get a 1 and a 2. You can roll a 1 in the first and a 3 in the second, and then a 1 and a 4, a 1 and a 5, 1 and a 6. Okay, let's write them all up. What else can happen? 2 and a 1, 2 and a 2. Don't talk to me, Mr. Park, I want to sleep, said Nagami. 3. What's going to happen when I write your college recommendation next year?
You write it?
Okay, you guys don't know how this works, yeah? Okay, if you're going to go to a selective college, why is that funny? Then you're going to need letters of recommendation, so you're going to have to find 2 of your junior teachers to write letters for you.
I just thought numbers.
Okay, and so you're probably going to say, okay, I'm just not going to ask Mr. Park. Okay, that's fine. But do you know that a letter of recommendation gets sent from the school as well? So you have your 2 teachers, but then from the school report. At the end of your junior year, did Mr. Fleming talk to you about this? I'm sure he did. The junior evaluation.
There's a junior evaluation.
Every one of your teachers, every single one of your junior teachers has to fill out an evaluation for you. And then from that, based on those evaluations, they pay people to type out the letter of recommendation from the school. Ugly.
This evaluation's like, on a scale of 1 to 5, how attentive is he in class?
Yeah, like work habits, creativity.
But it's all like on a scale.
Yeah, it's on a scale. Like non-existent to outstanding. No, that's how it is, okay? And then you know what they also put? Then you gotta write stuff. What are the first words that come to mind when describing this student? So when it's Nagami's turn, you know, just put ZZZ. That's the first words that come to mind.
What about me?
Non-existent. Yeah, but see, they want to write a positive letter, so they don't put anything bad in it. So when they see the ZZZ, they'll probably change it to, he's very rested. Something like that. Okay, can we finish this? Why did we even get talking about it? 3, 3, 3, 4, 3. Now some of you go, yeah, I know how this works, but no, you don't unless you see this for the first time. 4 and a 1, 4 and a 2, 4 and a 3, 4 and a 4. Since you guys don't bring your book, because I'm pretty sure this is printed in the book, even though I didn't look at it either.
Wait, so we have to write stuff out like that
Yeah, I would.
tonight?
Yeah, you're gonna write out the sample space. All the possible outcomes. Look, so how many elements will there be in this sample space before I finish?
36.
There's gonna be 36, how come?
6.
Yeah, 6 times 6, because the first die has 6 possibilities, the second one has 6 possibilities, 6 times 6, 36. And there you go, here's all 36, all in a matrix like that. Okay, so anytime you roll 2 dice, you know the denominator is gonna be 36, it's gonna be something out of 36. So now, but since you wrote them all out, you can answer any question. What's the probability of getting snake eyes? Now, if you don't know what snake eyes is, that's 2 1s. You know why they call it snake eyes? Because it's like this. See, snake eyes. Okay, so what's the only way you can roll a 2, or the total is a 2 right there? 1 out of 36. That's the probability. What's the probability of rolling a 12? What do you call a 6 and a 6? There's a nickname for that. It's called boxcars, I think. Any right there. So 1 out of 36. What's the probability that the sum of the two numbers adds up to 3? Where do the numbers add up to 3? Right there, 2 and a 1 or a 1 and a 2, so 2 out of 36. What's the probability that the sum of the numbers adds up to 4? No. Okay, see a pattern? Yeah? See, all these numbers add up to 4, so 3 out of 36. What's the probability of rolling a total of 5? Right there, 4 out of 36. What's the probability of rolling a 6? Well, the total is a 6. What about a 7? And then 8, 9, 10, 11, and 12 right there. You guys never saw this before, yeah? So tell me, what is the most common roll when you roll 2 dice? A 7, because how many different ways can you make a 7? 1, 2, 3, 4, 5, 6. So the answer is 6 out of 36. And that's why, if you know how to play craps, isn't rolling a 7 the key roll? That determines whether you win or lose, because that's the most common roll. You guys don't know how to play craps. Okay, there's all kinds of intricacies, but basically, you roll the die, 2 dice. You roll 2 dice. How do you win on the first one? 7 or 11, yeah? I think if you just roll a 7 or 11, you win. Okay, but if you don't roll a 7 or 11, like if you roll a 5, then what you have to do is you pick up the dice and you try to roll a 5 before you get a 7. And if you can do that, then you win. And then you can bet on all kinds of other things too, like how can you make a 5? Well, you can get a 3 and a 2, a 2 and a 3, a 4 and a 1, or a 1 and a 4. And so you can bet on those different things too. Okay, so here, let's see if we can extend it now. What if you roll 3 dice? See, now this is extending it. Okay? If I were to roll 3 dice, what would the denominator be? No. The first die has 6 possibilities, the second one has 6, and the third one has 6. What's 6 times 6 times 6? No, it's 216.
Oh.
It's 216. So when you roll 3 dice, the answer is always going to be something out of 216. Okay, but now let's see if you can think. Now, do I really want to write out all 216 things? No. So when the number gets big, we don't want to do that. Okay, what's the smallest number that you can roll when you roll 3 dice? A 1 and a 1 and a 1. That would be a 3. What would be the probability of that happening? 1 out of 216, right? That one's easy. Okay, but let's do a harder one. What's the probability if I roll 3 dice, the sum of the numbers adds up to 6, say? In other words, what's the probability of rolling a 6? Sum of numbers equals 6. So you know the answer is going to be something out of 216. So now you got to ask yourself, how can you roll so that what can you roll so that the sum of the 3 numbers equals 6? So let's write them up. 1, 2, and 3, don't they add up to 6? But then, what about a 1 and a 3 and a 2? How many? Okay, so here, this is where you can be smart now. So Mr. Park, instead of writing all this out, can I just use what I learned before? The permutations and combination stuff. Like, if you have 3 different numbers, or 3 different people, how many different orders can you put them in? We just learned this. Look, here, make the slots then. How many choices do I have for the first one? 3, 2, 1. Multiply that. So, 6, answer 6. So, without actually writing them all out, you have 6. So you can use what we learned before. Otherwise, if you're not going to learn what you did before, then write them all out. Okay, 1, 2, 3, 1, 3, 2. Okay, now I'm going to do the ones that start with 2. 2, 1, 3, 2, 3, 1. 3, 1, 2, 3, 2, 1. You get 6. Whatever, it doesn't matter, you get 6, okay? Is there any other way of getting a 6?
4, 1, 1.
4, 1, 1. But are there other orders? 1, 4, 1. 1, 1, 4. Is there a way I could have computed that? Yeah, remember Mississippi? How many different words can you spell with using the letters of the word Mississippi? That's what this is, except see, because you have two repeated ones. If all three of these were different, wouldn't the answer be 3 factorial? Remember? But since these two are the same, you have to divide by 2 factorial, and what does that come out to? Here, let me write it out for you since you guys want to sleep. 3 times 2 times 1. But what about me? I just had Taco Bell. I want to sleep. You see me sleeping? 2 times 1. These cancel out. You get 3. Yeah, or you can write them out. You still get 3. It doesn't matter. Okay, any other ways of getting a 6? 2, 2, 2. That's another way of getting a 6. Did we catch them all? Pokemon. We caught them all. Or are there others? Did we miss any Pokemon?
No.
No, that's it. So if you count them all, so the answer is 10 out of 216. Now, I'm not sure if I'm going to give you a problem that hard, but that's the kind of thinking you got to do. Okay, now tonight's homework, I just looked in the book, you have spinner problems. Spinner problems. That's easy though. You guys know what spinner problems are? Okay, so you have a circular thing, and then you have a spinner, so you spin it, goes like that, spins around. And what do you want to do, colors or numbers?
Numbers.
Okay, numbers 1, 2, 3, 4. Okay, I'm going to spin the thing twice. Okay, I'm going to spin it twice. What's the probability that the sum of the two numbers is a prime number? This is the kind I like to put on the quiz. You're going to spin the spinner twice. What's the probability that the sum of the two numbers that you got equals a prime number? So what you need to do is write out all the possibilities, the sample space. So what can happen when you spin this thing twice? You can get a 1 and a 1, right? A 1 and a 2, 1 and a 3, 1 and a 4. Oh, this is just like the dice problem. Yeah, 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4. 3 and a 1, 3 and a 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. Okay, there you go. So how many elements are there in the sample space? 16. So you know the answer is going to be something out of 16. So what did I say? I spin the spinner twice. What's the probability that the sum of the two numbers is a prime number? Okay, where do they add up to a prime number? Is 1 plus 1 a prime number?
Yes.
Yeah, what about 2? Is 3 a prime number?
Yeah.
What about 4?
No.
No, 5. Is 5 a prime number?
Yes.
Yeah. See how they come in diagonals again? What about 6? Is 6 a prime number? 7?
Yeah.
Yeah. What about 8?
No.
No, so what? What's the answer then? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is 9 out of 16. Once you write out all the possibilities, you can answer anything. Okay, let's do card problems. Okay, so just like we talked about yesterday, if I were to just randomly deal 5 cards from a deck of cards, how many possibilities are there? We did this yesterday.
5.
52, choose 5. Now, and remember what this came out to? 2,598,960, right? Do you really want to write out all the possibilities? No, but that's going to be the denominator. That's why I memorized it. Okay, so yes, what did we do yesterday? Royal flush and 4 aces, yeah? Let's do a different one. But we gotta do something that you can handle. What? We're doing poker! Okay, instead of 4 aces, let's do 4 of any kind, 4 of a kind then. Okay, so when you do 4 of a kind, this is how we do it. First you do a specific example, like 4 aces, okay? How many different hands have 4 aces in it?
4.
We did this yesterday. You guys cannot remember what happened 20, huh? Very good, 48. Everybody remember that? What?
Was there a video?
Did you send me an email to make a video?
It's okay.
Okay, wait, now let me explain it again because some of you just be fun of it. 40, where did that come from? How can you get 4 aces? You can get the 4 aces with the 2 of diamonds. Isn't that 4 aces? Or you can get the 4 aces with the 3 of diamonds. Or you could get the 4 aces with the 4 of diamonds. Do I have to keep going? Or you can get the, yes I do, I can get the 5 of diamonds. So how many, if you were to count all of these, how many would there be?
12.
No, 48. Because then after you finish the diamonds, then 2 of hearts, that's not a heart, 2 of hearts, 3 of hearts, 4 of hearts. Is that it? And then after the hearts, we'll get 2 of spades, 3 of spades, and so forth. And then after that, 2 of clubs,
Looks like a Christmas tree.
silence, 3 of clubs, and so forth. So 12 plus 12 plus 12 plus 12, that's how you get the 48, yeah? So this is how many ways you can get 4 aces. But now, what about 4 kings? Would be another 48, right? What about 4 queens? Would be another 48. What about 4 jacks? Would be another 48. So instead of adding up all those 48s, why not just times it by? Are you kidding? You guys don't know how to play cards. Look, got aces, kings, queens, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. That's it. How many of these are there in a deck? 13, just 13. Oh my gosh. You guys been playing cards all your life, haven't you? So, 4 aces, there's 48. 4 kings, there's another 48, another 48. So instead of adding up 48 13 times, what did we learn in elementary school? 48 times 13, there you go. This would be the probability of getting 4 of a kind. Now, you know the hardest, you know what the hardest one to figure out is in a poker hand? Try guess. Of all the probabilities, what's the hardest probability to compute? A probability of getting nothing. See, like, okay, what's the top ranking hand? We did yesterday.
Royal flush.
Royal flush. Okay, and then what comes before, under royal flush? 4 of a kind. And then what's ranking below 4 of a kind?
Full house.
Straight flush. Straight flush. And then full house. And then, you guys sure you guys play poker?
Oh.
They show it on ESPN all the
I
time.
don't watch this one.
How come I watched it? I'm nobody then. Full house, straight, 3 of a kind, 2 pairs,
1 high card.
1 pair, and then nothing. Now, you know why nothing is the hardest one to figure out? Because the only way you can figure out nothing is you gotta compute all of these first, and then you subtract it from 1. Because the probability of everything happening is 1, right? So you gotta compute all of these probabilities first, add them up, subtract from 1, that's how you get nothing. That's the hardest one to figure out. Okay, last thing, and you can finish early. Now again, just like when you did permutations and combinations, you gotta know when to add and when to multiply. When things can occur together, that's when you multiply. If things cannot occur together, that's when you add, okay? So, let me give you a problem. Let's say you have a deck of cards. I'm going to randomly select 2 cards, okay? Yeah, yeah. Did you watch the video? Okay, I'm going to randomly select 2 cards from a deck of cards. What's the probability that they're both, what do you want to do? Spades, aces, kings? Both clubs. Okay, so here we go. What's the probability of pulling out a club? So you have the 52 cards in a deck. I'm going to randomly reach in. What's the probability that I pull out a club on the first draw? Well, how many clubs are in the deck? 13. How many total cards are there? 52. So that's the, and you can reduce that to 1/4 if you want. But that's the probability of getting a club. Okay, now, 1 club is out of the deck already. What's the probability of me reaching in and pulling out another club? 12 out of 51, because I only got 51 cards left in the deck, right? And then how come I'm multiplying those numbers? Yeah, you're doing them together, but here, you know what? No, you know what? I'm gonna let you read the book on that. That's not gonna happen yet. Okay, anyway, so then you gotta simplify this. But you know, card problems are good because look, 13 goes into 52, 4 goes into 12, 3 goes into 51, 17 times. So the probability of pulling out 2 clubs is 1 out of 17. Okay, last one. I'm going to randomly select 2 cards. What's the probability that they're both kings? Okay, I'm going to reach into the deck. What's the probability of pulling out a king? 4 out of 52, correct? Because there's 4 kings in the deck. Okay, now, a king is already removed from the deck now. What's the probability of pulling out another king? 3 out of 51. There you go, that's your answer. And then now you got to simplify. 4 goes into 52, 13. 3 goes into 51, 17. So the answer is 1 over 500. Well, I'll tell you what, 20 times 20 is 400. So this is less than 400.
3, 20,
No.
3,
2.
Oh, wait.
2.
Shut up, Bert.
I'll give you a hint. Ends in a 1. Since 3 times 7 is 21.
5.
2.
221. You guys. Okay, so tonight's homework should be fun because now you can, most people like probability rather than just permutations and combinations. No, I forgot one problem. Sorry, you gotta do one more. Okay, this is the kind you see on the SAT and ACT sometimes, okay? Let's say you have 6 people. Alfredo, Bernardo, Carlos, Diego, Eduardo, Fuego, okay? I'm going to form a committee of 2 people. I'm just gonna randomly pick 2 people to be on a committee, okay? What is the probability that Carlos is on the committee? No, it doesn't work like that. You have to write out all the possibilities, okay? So, if I have 6 people, and I'm just gonna randomly select 2 people to be on the committee, how many possibilities will there be? Okay, well, let's write them up. Well, you guys should know, we learned this. If you have 6 people, how many different ways can I select 2 of them to be on the committee? Isn't the answer just 6 choose 2? This was last night's homework. And if you compute that, that's going to be 6 times 5 over 2 times 1. 2 goes into 6, 3 times 5. There's going to be 15. Okay, so let's write out all 15. How do you do that? I can pick A and B, A and C, A and D, A and E, and F. See, I did all the ones with A, now let's do the ones with B. B and C, E and D, B and E, B and F. Now do all the ones with C. A and D, E and E, we're almost done. And then E and E, E and F. And finally, E and F. Does that add up to 15? Yeah, so you can double check your work like that. So you know the answer is going to be something out of 15. What is the probability that Carlos will be on the committee? Well, just count all the ones that have Carlos. Carlos, 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 Carlos. That's it. So what is that?
5.
Did I miss any? No, so 5 out of 15, which is 1/3. There you go. So if you can write out the sample space, probability is easy. All right, now you guys can sleep. What do you mean? I've been sleeping the last 15 minutes, Mr. Park. Yes. We just had lunch. Why do you want to go snack bar? No, the answer is no. We just had lunch. Yes. All right. Is this volleyball? All right. Okay, go. Go snack bar. You guys gotta come right back. Okay, wait. From now on, you enter the snack bar once a week. So you guys going now. That's it for the rest of the week.